Hey guys, this video here we're going to talk about is a video on naming ions, which is actually pretty easy, but there's a little differentiation to it, and ions start out real small and they get pretty big. Okay, monatomic ion. What is it? It's a single ion, but it consists of only one atom, and the respective charges are determined by their periodic table. Now there are two types of monatomic ions. Positive and negative. So the positive is cation, negative is anion. Okay, now remember, this is very important. All elements of the representative groups are 1A, 1 plus, 2A, 2 plus, and so on and so forth, all the way down to 7A, which is minus 1. Your nonmetals start from 4A to 8A. Okay, and your metals are 1A, 2A, 3A. Now, naming cations. Cations are located in groups 1A, 2A, 3A, like I just mentioned. Metals lose electrons, okay? So when something loses electrons, okay, it's going to have a positive charge. So think of a couple, a positive and a negative. If you lose electrons, it exposes a positive charge. So you have a positive and a negative to start with. All right, so cations, they form ions with positive charges equal to the group number. The names of cations are the same as the name of the metal, followed by cation. So it's actually very simple. So it's going to be the name of the metal plus cation. Okay, so let's look at Li plus, Mg2 plus, and Al3 plus. Now, lithium's in group 1A, so it has a plus 1. Magnesium's group 2A, so it has 2 plus. Aluminum has 3 plus because it's in group 3A. So very simple. It's just going to be called, lithium is going to be lithium cation, no change to the name. Magnesium is just magnesium cation, and aluminum is just aluminum cation. Now, if they weren't charged, it would just be called the lithium atom, magnesium atom, aluminum atom. But because they have the charges, they lost electrons, the cation goes after it. Okay, naming anions. Remember, anions located in group 4A, 5A, 6A, and 7A. Nonmetals gain electrons. Okay, so what happens? Nonmetals have, let's just talk about this, have, say, a positive charge, or I'm sorry, a proton and an electron. They gain an extra electron. So let's just say if it has one proton, one electron, and if it gains a second electron, it's going to have a charge of 2 minus. It's going to have an extra charge. Okay. Now, they form ions with a negative charge, so it's going to have some negative next to it. The charge of a nonmetal is determined by how many electrons it gains. Okay, so we can look at the table. Group 4A, they always have a 4 minus. Group 5A has a 3 minus, 6A has a 2 minus, and 7A has a 1 minus. You can just remember that. Or another way to calculate the charge is to subtract 8 from the nonmetal's group number. Okay, 4 minus 8 is minus 4. 5 minus 8 is minus 3. 6 minus 8 is minus 2. 7 minus 8 is minus 1. Okay, that's essentially where it comes from. Okay, now, naming anion. The name starts with the stem of the element's name, and you must add the IDE plus anion. So essentially the name is going to be a little different than the cations. Okay, so each element that gains electrons is going to have a slight variation. Okay, but they will all have one thing in common: ide anion. So let's take a look at some different anions. So you have F minus, O2 minus, N3 minus. Now they all gained electrons. Fluorine gained 1, oxygen gained 2, nitrogen gained 3. Okay, fluorine's in group 7A, oxygen's group 6A, nitrogen group 5A. So the names of these are as such. F becomes fluoride anion. So fluorine gains electron, becomes fluoride anion. Oxygen gains 2 electrons, becomes oxide anion. Nitrogen gains 3 electrons, it becomes the nitride anion. Okay, so the IDE is present in the name of the anion. Now, transition metals. Okay, they're the D block elements. They're a little different. Okay. Now let's take a look. Many transition metals form more than one cation. Okay, so for example, chromium can lose 2 electrons, and it can also lose 3 electrons. There's different isotopes of chromium, but we're not going to really deal with that too much right now. So because these elements lose a multitude of different charges, okay, we need to clarify which one it has. Now the elements found in 1A, 2A, 3A, 4A, 5A, 6A, 7A, and those only gain or lose one specific number of electrons. These, we don't know which one they lose. Okay, so for example, chromium lost 2 and chromium lost 3. Okay, chromium here lost 2, this one lost 3. Okay, so we call this the stock naming system. Okay, the transition metal's charge must be represented with a Roman numeral, and the Roman numeral dictates what charge it has. Okay, so let's take a look. If it loses 1 electron, it's going to have Roman numeral 1. If it loses 2 electrons, Roman numeral 2. If it loses 3 electrons, have Roman numeral 3, and so on and so forth. So these are your Roman numerals. IV is 4, 5 is V, 6 is VI, 7 is VII, and that's pretty much the furthest we go. You don't really get to 8, but it's VII, 9 is IX, and 10 is X. So those are the Roman numerals you need to be familiar with. Like I said, you only really need up to 7 at that. Okay, so let's look here. So we have iron, copper, and manganese. Iron has the ability to lose 2 amounts of electrons at 2 different times. So iron has the ability to form 2 different charges, just like copper and manganese. Okay, so the first one in parentheses, Fe2 plus, is the loss of 2 electrons. Fe3 plus is loss of 3 electrons. So we name that accordingly. So it's iron 2 cation for 2 plus and iron 3 cation for 3 plus. And just like here, copper loses 1 and copper loses 2. So this 1 in copper, we call it copper 1 cation. Cu2 plus is copper 2 cation because it lost 2 electrons. And manganese, okay, has a Roman numeral Vi to represent the 4 and VII to represent the 7. So manganese 4 cation and manganese 7 cation, okay, respectively. That's the order that they are seen, okay. Now, there are elements that have basically potential to have 5 positive charges, and if you run into that, you just simply, whatever charge it has, you just use the correct Roman numeral to accommodate the charge, only for transition metals. Now, there's 2 poor metals, okay, 2 very important ones, lead and tin, okay, they are not in the D block, they are in the P block. Therefore, you must use a Roman numeral with them, just these 2. Okay, now lead 2 is Pb2 plus because it lost 2 electrons, and Pb4 plus is going to be lead 4. Okay, tin is 2 plus. Okay, tin 2 and tin 4 is Sn4 plus. Okay, so you must make a mental note of this and remember this as you go. Okay guys, now there's some metals, transition metals especially, that only have 1 charge and they are found in D block, but we do not use a Roman numeral for these. That includes cadmium, zinc, silver, zirconium, tantalum, and technetium. Okay, most importantly, the first 4 are the ones you have to really remember. The last 2, not so much. Okay, so you do not need a Roman numeral with these. Ag is just 1 plus, Zn is just 2 plus, CD is just going to always be 2 plus. You're not going to have a CD 3 plus, CD 1 plus. It's always going to be 2 plus. These charges here are always going to be these charges and never changed. Unlike copper and iron, etc., like we talked about, like the other transition metals. Okay. Now, there's another type of ion called the polyatomic ion. Now, these ions are going to be a little bit bigger. They're going to have more than 1 atom bonded, and they're going to be covalently bonded, and it behaves as a 1 unit and carries a charge. So in these polyatomic ions, you're going to see parentheses, and they must be used to block in what makes the ion the ion. Outside the parentheses, you'll see a charge. Okay, this is known as phosphate. All right. They're also known as oxyanions because many contain oxygen. Okay, so oxyanions are very important in chemistry. Okay, now there's polyatomic ions in your textbook. The ones that have the 8 in it is the name of the ion with the greater number of oxygens. Okay, so we have, for example, sulfate, nitrate, phosphate. Okay, so sulfate is SO4, nitrate is NO3, phosphate is PO4. Now they're in parentheses. Outside the parentheses are these charge numbers. You cannot find these charge numbers on the periodic table. These charges are basically developed from the bonding and the electron sharing and how many electrons are left over, for example, if you do a Lewis dot structure. Okay. Now, ITE in polyatomic ions, I like to remember like lighter is the ite. So if you think something's lighter, it's going to have fewer. So in this case, if you're looking at polyatomic ions, the one with the ITE is the name of the ion with the smaller number of oxygens. So let's take a look at these three. Okay, sulfite, nitrite, and phosphite. Okay, sulfite has SO3. Nitrite is NO2. Phosphite is PO3. They're all in parentheses, and they all have a charge. Now, the ATE ions that we saw a slide before were sulfate, nitrate, phosphate. They all had one more oxygen. These are the ites, so they're lighter. They have one fewer oxygen each. Now, there's a couple prefixes that you need to know. Okay. Now, there's hypo and per. Hypo is given to an anion if it has fewer oxygens than ite, so it's one less than ite. Okay, now per is given to an anion if it has one or more oxygen than 8. So let's take a look here. We have ClO, which is the one with the fewest oxygens, all the way to ClO4. The one all the way at the bottom is actually called perchlorate because it's one more than the actually chlorate. This right here, ClO2, is chlorite, so you take one away, it's called hypochlorite. Okay, so hypo at the bottom and per at the top. Now, one very important note, and I like to stress this enough. I can't stress this enough, all right? Now, there's monatomic ions and there's polyatomic ions. Polyatomic ions are the ones that are found on a table, okay, that have more than one atom bonded to each other. Monatomic ions are one single element where it gains or loses an electron. So for example, remember, monatomic, N3-, that's a nitride. Down here, common mistake is to think that nitrate, NO3, is actually N3-, or vice versa. Some people tell me that N3 is nitrate. I don't get it. I don't know. Okay? Eights and ites are polyatomics. Ides are monatomic. So you have sulfide, sulfate, phosphide, phosphate. Okay? If you're confused with that, just mono means one. Poly means more than one. Okay? And that's it. Those are ions. Just try to become familiar with it. And that's basically it, guys.